Hello world, my name is Caleb. Today is August 31st, 2025, and I am introducing what I believe is the world's first non-binary graphing calculator. So what is a non-binary graphing calculator, you may ask? So we'll compare with a binary graphing calculator, like any conventional graphing calculator, like a TI-85 or TI-89 or Desmos, which is an awesome free online normal graphing calculator. And you can see basically the way it works is when you have an equation like y equals x, wherever the left side and the right side of the equation are exactly the same, they're equal, the line is drawn, and everywhere else basically is just white with the grid. Um, and so, for example, at 0, comma 0, hey, y equals 0, x equals 0, so the equation is true, so the line is there. Same at 1, comma 1, where x, the x-axis, or the horizontal axis is x, the vertical axis is y, and so right here is x is 1 equals 1. Up here, it's x equals 1, y equals 1. You plug those numbers into the equation. It's true, so you draw the line there. FuzzyGraph, however, does not only draw the line where the equation is exactly equal, but it also draws color where the equation is close to equal. And so you can see that that results in basically a gradient, which is pretty. You can also turn the axes off if you want to see what it looks like on its own. Anyway, so it's basically, and actually, if you look over here at the little mouse over thing, you can see x comma y. So over here, I'm at 2.8 something, comma y equals negative 1.755, and at this point, the error is 4.614. Over here on the line, the error should be around 0. Yeah, right there, the error is 0.006. Or if I try to go to 1, comma 1, it's hard to get my mouse exactly there. Oh, there we go. Yeah, all right, there you go. So at 1, comma 1, the error is 0. And so you can see that. You can also turn down. By the way, the technical difference for what FuzzyGraph is doing is it's making the graph more fuzzy. Just kidding. Or, but I do call it the fuzzy level. We can turn it down, by the way. Really, I think probably the more technical name for it would be an error gradient. So FuzzyGraph is graphing the error gradient. And so it's something that you can use to make pretty pictures. And I've basically used this technique to do most of my art stuff that I do at gods.art. Anyway, a question that I think could be asked here is, okay, so what is it just a pretty picture? Is it just, or is it just elaborating on a normal graph? Is it just a pretty picture? And the answer is actually no. It's not just a pretty picture. And it's, you might say, well, is this just, is this, which one's more true, right? And really, in some ways, FuzzyGraph is giving more of the mathematical topology than you would see in a normal graph. And so, I think a fair question might be, well, but is this just kind of like, is it like a blur effect, or is it like a Gaussian blur? And the answer is no there again. So with a linear equation like this, for example, you don't need the fuzzy graph. Okay, like even on a regular graph over here, you could pretty much say, hey, where's the error higher or lower at? Well, the further you get away from the line, the higher the error is, right? Like here, right on the line, the error is 0. As you get away, it's a smooth gradient. Is FuzzyGraph even showing anything different? And so look at a different function. So let's do x squared plus 4. You can notice how you do the power sign in FuzzyGraph. Now that's way too fuzzy. Let's turn down the fuzz on this one. Okay, yeah. So this equation is very different looking. Actually, let's look at this equation in Desmos by comparison. X squared plus y squared. So you can see, again, what if we're trying to figure out what's the error at each point? Well, like before, you would think, hey, the error closer to the line will be lower. On the line, the error is 0, right? So closer to the line, the error should be lower, but it should be higher the further away you get, right? But this is not always the case. So this function, I've been calling this the quasar equation, because I saw this and I was like, look at this black hole, and like you don't see this at all, like in a normal graph like this. But over here, you can see clearly. It looks like there's this like black hole, and it looks like it's like sucking in this energy beam or something. And so, okay, so where's the error, higher or lower? Well, in this graph, you can tell just by looking. Hey, it's not exactly a linear error. As okay, so the error way out here is like 2 point something. The error way out far away, as far away as we can get from the line. And on the line, you can see the error, as you expect, is close to 0, or if we're right on the line, it'd be 0. But look what happens over here in the black hole section. 56, 7. These numbers are of error. If you look in the bottom right, these error values are way higher. And actually, if you zoom in here, it's asymptotically goes up. And so you can kind of just see kind of the behavior of the math in a way. And so, like with FuzzyGraph, you can actually see more of the mathematical topology. It's almost like the difference between if you were looking at a map with islands, you'd see the outline of where the land meets the water. But if you could see below the water surface, there's there's underwater mountains and valleys, and so it's kind of like FuzzyGraph. Right here, this black hole. If you turn this into a three-dimensional graph where you replace the color with the height, this would be a big hole that would basically go down, I think, basically forever. Kind of wild. Anyway, okay, so FuzzyGraph, I think it makes pretty pictures. There's all these color maps you can choose from and stuff like that. By the way, and you can do little things like invert the color. One other feature, you can save a graph. So if you got a graph and you want to send it to someone, you can just click share, copy the URL, and then you can just paste that URL, and that URL basically contains all of your settings, and so it'll even where you're zoomed at, you can zoom by clicking the plus button, zoom out by clicking the minus. You can drag to pan the graph, and this should work on all devices, by the way: iPhone, iPad, Android tablets, all of that. Additionally, something I want to share is that if we just go to fuzzygraph.com normally, so FuzzyGraph, there's actually so it's not spying on you. There's no server component, in fact, and this is kind of from a technical perspective, but this means something very practical, which is you can actually save FuzzyGraph. So it's actually written in a way, very intentionally, where my local FuzzyGraph. So I can save this as a file on my desktop. And watch this. I'm actually going to go off the internet. And I'm going to open this file. It's just a file, right? But this file is itself the entire FuzzyGraph application. It's actually a 1 megabyte single completely self-contained .html file that you can download and you can use, not being disconnected from the internet. And you can y equals sign of x You can, no, that's too boring. Make higher, up the frequency, right? Up the fuzz, more. So you can use this. What's another one? Good one. You can use this at anywhere, offline on any device. And so just, part of my goal, a big part of my goal with this was to basically, so when I first encountered graphing in high school as a sophomore, I was just fascinated. Graphing calculators and stuff I actually went from hating math to like it being one of my favorite subjects. And so and there's graphing is already taught, but the thing is, it can be a lot more beautiful. It can be a lot more interesting. And so I would like more people to encounter this kind of visualization of math. And it's free to use, easy to use. I'm going to be adding more features soon. There's all these mathematical functions, or if you know their name, you can just use them like sine, cosine, tangent, blah blah blah. And anyway, if you're a teacher in a school, you have my approval to use this free of charge. You have my approval. Anyone has my approval to use this free of charge. And I would. The nice thing is it doesn't cost anything, so there shouldn't be any boundaries. You don't have to get approval from anyone to use it in any context. So I think that's all I wanted to say. I try to keep this short. Thanks, and hope that you enjoy FuzzyGraph, and hopefully more people will appreciate the beauty of math. Thanks. Bye.